What if the most violent act in the universe is also its most creative force? What if the complete and utter annihilation of cosmic order is the very mechanism that builds structure sparks life and gives the cosmos its majestic evolving character? We are taught to see destruction and creation as opposites as the beginning and the end, but the universe in its infinite wisdom knows they are two sides of the same coin, two movements in the same celestial symphony. And nowhere is this profound, terrifying paradox more brilliantly displayed than in the silent, colossal collisions of galaxies. Look here at this masterpiece of gravitational chaos. You are seeing two entire universes of stars, the antennae galaxies, locked in a cosmic embrace that has lasted for hundreds of millions of years. This is not a snapshot of an explosion. It is a slow-motion catastrophe of unimaginable scale, a dance choreographed by the invisible hand of gravity. Long, graceful arcs of stars and gas like golden ribbons flung across the dark stream away from the wreckage. These are tidal tails torn from the parent galaxies by the brutal stretching forces of their encounter. At their heart, where the two galactic cores are merging, there is a firestorm. A furious blue glare, the light of millions of newborn superhot stars, illuminates clouds of incandescent pink hydrogen. It is a scene of both exquisite beauty and savage violence, a cosmic battleground that is simultaneously a stellar nursery. To us it appears as a static portrait, a breathtaking image captured by our telescopes. But if you could watch this unfold over the eons it truly requires, you would witness a transformation of profound significance. You would see two perfect spinning spirals, serene and majestic in their solitude, begin to feel a subtle, insistent pull from across an immense void. Their stately rotation would begin to warp. Their elegant arms would start to unwind, pulled and distorted by a force they cannot escape. What began as a graceful pass-by would become an inescapable gravitational trap, a slow, spiraling fall into the heart of a tempest. The very fabric of these galaxies, the delicate architecture of stars and nebulae built over billions of years, is being systematically dismantled, shredded and rearranged. This is not a gentle merger. It is a galactic apocalypse. And yet within that apocalypse the seeds of a new creation are furiously sown. The question that has haunted astronomers since we first witnessed these celestial apparitions is not simply what is happening, but why? What is the ultimate purpose of this spectacular destruction? For decades our vision of the cosmos was one of peace and permanence. We saw galaxies as island universes, a term coined by the philosopher Immanuel Kant, and later championed by astronomers like Edwin Hubble. They were imagined as static, isolated cities of light, separated by impassable oceans of intergalactic space. Each was thought to be on its own journey, evolving in quiet solitude, its destiny written entirely within its own gravitational boundaries. The universe was a tidy place, a great dark museum of celestial objects, each in its proper display case. This comforting view, however, began to crumble as our eyes grew sharper. In the mid-20th century, astronomers like Halton Arp began compiling catalogues of what he termed peculiar galaxies. These were the cosmic misfits, the oddities that didn't fit Hubble's elegant classification scheme of spirals and ellipticals. They were warped, lopsided, asymmetrical. Some had strange jets erupting from their cores. Others were connected by faint luminous bridges as if reaching out to one another across the darkness. Arp's Atlas of Peculiar Galaxies was a rogues gallery of cosmic disturbances, and at first many were dismissed as mere curiosities. They were the exceptions that proved the rule of an otherwise orderly universe. But what if they weren't the exception? What if they were in fact the rule? What if the serene perfect spirals we so admire are merely a fleeting temporary state, a moment of peace before or after a violent encounter? This revolutionary idea shifted our entire perception of the cosmos. The universe was not a static museum. It was a dynamic, evolving ecosystem. And in this ecosystem, galaxies were not islands but continents, drifting on the unseen currents of space-time, destined to collide, to merge, to devour one another in a cosmic version of natural selection. The evidence became undeniable. With the advent of more powerful telescopes both on the ground and in space, we began to see these interactions everywhere we looked. In the distant early universe, we saw small misshapen proto-galaxies swarming together, building the first great galactic empires. In our own cosmic neighbourhood, we saw the lingering scars of past collisions, subtle streams of stars orbiting larger galaxies like ghosts of the victims they had consumed. The tranquil portrait of the cosmos was shattered, forever replaced by a far more dramatic and interconnected reality. The story of the universe was not one of quiet solitude, but of constant transformative interaction. To understand how this happens, you must first unlearn what your eyes tell you. When you see an image of two galaxies merging, you see a solid, swirling mass of light. It looks like two paintballs hitting each other, a messy, chaotic splash. But the reality is far stranger and far more elegant. A galaxy is mostly empty space. If you were to scale the Sun down to the size of a single grain of sand, the nearest star, Proxima Centauri, would be another grain of sand over 4 miles away. The stars within a galaxy are incredibly remote from one another. So when two galaxies like the antennae collide, the individual stars almost never ever hit each other. They simply pass through one another like phantoms, their orbits dramatically and permanently altered by the combined gravity of the opposing galaxy, but physically untouched. It is a ghost army passing through another ghost army on a celestial battlefield. The real battle, the one that reshapes everything, is fought not between the stars, but between the gravitational fields they collectively generate and in the vast diffuse clouds of gas and dust that drift between them. Gravity is the ultimate architect of this process. It is a force of infinite patience and inexorable power. The initial pull between two galaxies can begin when they are millions of light years apart. It is a whisper at first, a barely perceptible tug, but over the cosmic ages it is a siren song that cannot be resisted. As they draw closer, this force escalates dramatically. It doesn't just pull the galaxies together as a whole, it exerts a differential pull. The side of a galaxy closer to its approaching partner feels a much stronger gravitational force than the far side. This is the origin of the tidal forces, the same phenomenon that causes the Earth's oceans to bulge towards and away from the Moon, but magnified on a scale that is almost beyond comprehension. Imagine a vast, spinning disk of stars. Now imagine a force that grabs the nearest edge and pulls it forward while simultaneously leaving the farthest edge to lag behind. The galaxy is stretched. Its beautiful spiral arms, once tightly wound, are drawn out into long, tenuous streams. These are the spectacular tidal tails we see, cosmic breadcrumb trails marking the history of the interaction. At the same time, the galaxies are squeezed along their perpendicular axis, their internal structures compressed and shocked. Stars are thrown out of their comfortable circular orbits and cast onto wild, chaotic new trajectories. Some are flung far out into intergalactic space, destined to wander alone for eternity. Others are funneled directly towards the galactic centre, where they will feed the growing monster that lurks there. The galaxy's very skeleton, its gravitational structure, is broken and reformed. It is a process of cosmic torture, a celestial body being stretched on a gravitational rack, yet it is this very torture that triggers a glorious renaissance. For between the stars lies the true fuel for creations, the interstellar medium. These are the vast cold dark clouds of hydrogen gas and microscopic dust, the raw material from which future generations of stars and planets will be born. In a normal undisturbed galaxy, these clouds can drift for billions of years, slowly collapsing under their own gravity to form new stars at a steady measured pace. But during a merger, this gentle process is thrown into overdrive. As the two galaxies pass through each other, their gas clouds, unlike the stars, cannot simply ghost past one another. They collide directly, smashing together at hundreds of kilometers per second. This collision creates immense shock waves, cosmic sonic booms that ripple through the interstellar medium. The gas is violently compressed, squeezed to densities it would never otherwise achieve. This compression is the trigger. Across thousands of light years, these shockwaves ignite a firestorm of star formation, an event we call a starburst. In the span of just a few million years, a merging galaxy can form stars at a rate hundreds or even thousands of times greater than a stable galaxy like our own Milky Way. Vast regions, once dark and placid, erupt in the brilliant blue-white light of massive young stars. These stars live fast and die young. They burn through their nuclear fuel in a cosmic heartbeat, then explode as brilliant supernovae seeding the galaxy with the heavy elements, carbon, oxygen, iron, that are essential for the formation of planets and ultimately life itself. The collision as the act of destruction becomes a celestial pressure cooker, forging the very building blocks of new worlds from the wreckage of the old. The dance of giants is not just reshaping galaxies, it is enriching the universe. This brings us to the core of our investigation, the central thesis of our journey. These cataclysmic events are not accidents. They are not rare spectacles on the cosmic stage. They are the primary engine of galactic evolution. The universe we see today, with its grand mature spiral galaxies and its colossal, round elliptical galaxies, was built through a long and violent history of these mergers. In the dawn of time, the first galaxies were small, fragile and misshapen. It was through countless collisions and acquisitions, a continuous process of galactic cannibalism over 13 billion years, that they grew into the giants that now dominate the cosmic landscape. A grand spiral like Andromeda is not a single pristine entity. It is a composite dynasty built upon the ruins of the dozens, perhaps hundreds of smaller galaxies it has consumed over its lifetime. Every star in its halo, every globular cluster in its orbit is a potential witness to this violent past. So when we look at these interacting systems, we are not just witnessing a beautiful destructive event. We are seeing a fundamental process of the cosmos in action. We are watching the universe build itself. But this revelation only opens the door to deeper, more profound questions. What happens to the supermassive black holes that we now know reside at the heart of nearly every large galaxy? When two galaxies merge, do their central black holes also merge? And if so, what happens when two objects each with the mass of millions, or even billions of suns collide and become one? What kind of gravitational scream would such an event send tearing through the fabric of space-time itself? How does this process shape the final destiny of the new larger galaxy that rises from the ashes? And what does it mean for us? Because this is not a distant academic story. It is our own future. We are living inside one of these dances. Our home, the Milky Way galaxy, is not on a solitary path. We are hurtling through space at over 1 million kilometers per hour on a direct, inescapable collision course with our nearest large neighbor, the Andromeda galaxy. In roughly 4.5 billion years, our two galaxies will begin their own tidal dance. The night sky of some future Earth, or whatever worlds may exist in our solar system, then will be transformed. Andromeda, now a faint fuzzy patch of light to the naked eye, will grow to fill the entire celestial dome. Its spiral arms and our own will be torn asunder, flung across the heavens in brilliant fiery arcs. The very constellations that have guided us, that have been woven into our myths and our science for millennia, will be erased, replaced by a chaotic, brilliant and utterly new vista. Our solar system will likely be thrown onto a completely new orbit, perhaps cast far out into the newly formed galactic halo. The sky will be alight with the fire of 1 trillion stars, a starburst of unimaginable intensity. It is a destiny written in the laws of physics, a final spectacular act in the story of our galaxy as we know it. And by studying the dances of other giants across the universe, we are in a very real sense catching a glimpse of our own ultimate fate. We are piecing together the story of cosmic evolution, a story of violence, of creation, of transformation. A story that began with the Big Bang that built the galaxies we see today, and that will culminate for us in a final glorious merger. This is the story of what happens when giants dance. There is a violence in the universe, a silent, slow-motion ballet of destruction and creation that unfolds over 1 billion years. Its dancers are not stars, but cities of stars. Colossal structures of dust gas and dark matter, each one a self-contained cosmos home to hundreds of billions of suns and perhaps trillions of worlds. We call them galaxies, and for nearly all of our history we believe they danced alone. We saw them as majestic, isolated islands adrift in an infinite empty ocean of night, each pursuing its own solitary destiny, forever separate, forever serene. This understanding gave us a sense of order, a feeling of comfort in the vastness. It was a beautiful, elegant and profoundly mistaken view of reality. The truth woven into the very fabric of space-time is infinitely more chaotic, more creative and more terrifying. The universe is not a silent ballroom. It is a contact sport. To understand how deeply this modern revelation cuts you, must first journey back with us to a time when our own galaxy, the Milky Way, was the entire universe. For centuries, astronomers looked out at the heavens and saw a familiar bounded home. There were the steadfast stars, the wandering planets, and then there were the others, faint ethereal smudges of light, ghostly clouds that refused to resolve into sharp points. They were catalogued by observers like Charles Messier, who saw them as mere nuisances in his hunt for comets. He called them nebulae, Latin for clouds, and that is what they remained, curious local phenomena suspended within the grand architecture of our own star system. Some, like the Great Nebula in Orion, were clearly stellar nurseries, glowing wombs of gas birthing new suns. But others were different. They possessed a distinct pinwheel structure, a spiralling form that seemed too organised, too deliberate to be a simple cloud. These were the spiral nebulae, and they were a persistent, quiet mystery. They existed on the periphery of astronomical thought, beautiful but baffling objects without a proper home in the cosmic ledger. Were they solar systems in the process of formation, swirling vortices of primordial gas coalescing into a new star and its planets? Or were they something else entirely? The debate raged, fueled by the limitations of the era's technology. The largest telescopes on Earth could see their magnificent shapes, but they could not pierce their luminous veils. They remained soft, indistinct, their true nature tantalizingly out of reach, their immense distances utterly incomprehensible. They were treated as curiosities, artworks of the cosmos hung in our local gallery, forever contained within the Milky Way's borders. The universe was a single grand empire of stars, and we were its inhabitants. Everything else was just decoration. This cosy, contained vision of the cosmos was shattered by one man and one mountain. The mountain was Mount Wilson in California, a peak thrust high above the shimmering haze of the Los Angeles basin, offering a crystal-clear window into the heavens. The man was Edwin Hubble, a former lawyer drawn to the profound questions of the cosmos. In the early 1920s, armed with the new 100-inch Hooker telescope, then the most powerful instrument on the planet, Hubble aimed its colossal mirror at the most famous of the spiral nebulae, Andromeda. Night after painstaking night, he captured its faint ancient light on immense glass photographic plates. He wasn't just looking at the nebula, he was hunting for individual stars within it, trying to resolve the irresolvable. And then he found it. A single flickering point of light on a photographic plate. It was not just any star. It was a Cepheid variable, a rare and miraculous type of star that acts as a cosmic standard candle. These stars pulsate, brightening and dimming with a rhythm that is directly mathematically linked to their true intrinsic brightness. By comparing how bright a Cepheid appeared to be with how bright it truly was, Hubble could calculate its distance with unprecedented accuracy. It was like seeing a lighthouse in the distance and knowing the exact wattage of its bulb. The faintness of its glow would tell you precisely how far away it was. The calculation Hubble performed was one of the most consequential in the history of human thought. The result was staggering, paradigm-destroying. Andromeda was not a nearby cloud of gas. It was not a nascent solar system within our own galaxy. It was located nearly 1 million light-years away, a distance so vast it dwarfed the known scale of the Milky Way. This single discovery, this one flickering star, did not just expand the universe, it multiplied it. Andromeda was a galaxy in its own right, an island universe, as the philosopher Immanuel Kant had once speculated, a sister city of stars comparable in size and splendour to our own. Suddenly the cosmos was not a single empire, but a potentially infinite archipelago of them. The faint smudges in the sky were revealed for what they were, the light of other realms, other Milky Ways, each separated by gulfs of darkness so profound that light itself took millions of years to cross them. With this new, incomprehensibly vast universe laid bare before him, Hubble embarked on a second great quest to bring order to the chaos. He became the first great celestial cartographer, the Linnaeus of the Galaxies. He spent years meticulously studying photographic plates from Mount Wilson and Palomar, gazing upon thousands of these newfound stellar continents. He saw that they were not all alike. They came in a stunning, almost zoological variety of shapes and sizes. To make sense of it all, he developed a classification system, an elegant visual sequence that is still used to this day. It is known as the Hubble tuning fork diagram, and for a time it seemed to represent a perfect, almost evolutionary order to the heavens. On one prong of the fork he placed the elliptical galaxies. These are the ancient behemoths of the cosmos, vast featureless spheroids of old yellowed stars. They range from nearly perfect spheres, which he labelled E0, to more elongated, football-like shapes classified as E7. Ellipticals are placid, almost retired galaxies. They lack the vibrant gas clouds and stellar nurseries that define their more dynamic cousins. Their era of frantic starbirth is long past. They now drift through the darkness like glowing embers of a once roaring cosmic fire, their constituent stars locked in stable, predictable orbits around a common gravitational centre. They represented a kind of cosmic maturity, a state of quiet equilibrium. On the other prong he placed the majestic spirals, the category to which our own Milky Way belongs. These are the dazzling pinwheels, the icons of the cosmos. Hubble subdivided them based on the tightness of their spiral arms and the size of their central bulge. SA types have large dominant central hubs and tightly wound, almost indistinct arms. As you move along the sequence to SB and then SC, the central bulge shrinks, and the arms unfurl, becoming more open, graceful and clearly defined. These arms are not solid structures, but luminous traffic jams, density waves sweeping through the galactic disk, compressing gas and dust to trigger spectacular bursts of new star formation. They are painted with the brilliant blue light of hot young massive stars and traced by the pinkish glow of energized hydrogen gas. They are active, vibrant and alive with creation. Bridging the two prongs were the lenticular galaxies, a sort of intermediate form possessing the central bulge and disk of a spiral but lacking the glorious arms. And separate from it all, he placed the irregulars, a catch-all category for those galaxies that seem to have no discernible structure at all, messy, chaotic splashes of stars against the cosmic canvas. Hubble initially thought his tuning fork might represent an evolutionary path that perhaps irregular galaxies settled down to become spirals, which then used up their gas and faded into quiescent ellipticals. While we now know this simple picture is incorrect, the diagram itself was a monumental achievement. It gave humanity a framework, a language to discuss the grandest structures in creation. It reinforced the idea of galaxies as distinct, well-behaved objects, each falling into a neat category like specimens in a celestial museum. The universe, though vast, appeared orderly and comprehensible. But even as this elegant system brought clarity, a disturbing new mystery was emerging from the deep sky photographic plates. Among the thousands of perfect ellipticals and graceful spirals, astronomers began to notice outliers, oddities, galaxies that stubbornly refused to fit into Hubble's tidy boxes. The astronomer Holton Arp, working in the 1960s, became obsessed with these cosmic misfits, compiling a famous catalogue that he called the Atlas of Peculiar Galaxies. These were not serene island universes. They looked like they had been through a catastrophe. They looked damaged. You could see galaxies that appeared impossibly stretched out as if caught on a cosmic rack. Some were connected by faint luminous bridges of stars, tethers of light stretching across hundreds of thousands of light years of barren space. Others had long ghostly tails, ethereal streamers of suns and gas flung out into the intergalactic void, like the spray from a crashing wave. There were galaxies that looked like they had been torn asunder, their spiral arms shredded and flung into disarray, their cores displaced or even multiple. And perhaps most bizarre of all were the ring galaxies, celestial smoke rings, with a bright knot of stars at their centre, as if another smaller galaxy had been fired through them, like a cosmic bullet leaving a ripple of star formation expanding outwards in its wake. These peculiar galaxies were a direct challenge to the static, orderly paradigm. They were the evidence of a crime scene scattered across the cosmos. A graceful spiral arm is the product of billions of years of stable gravitational choreography. To see one so utterly distorted, so violently rearranged, implied the action of some colossal external force. The faint bridges and tails were even more damning. Stars are bound by their home galaxy's immense gravity. For them to be pulled out into these vast tenuous structures required a gravitational disturbance on an almost unimaginable scale. It was as if an invisible hand had reached across the void and stirred the cosmic pot, flinging stars around like flecks of dust. The quiet solitude of the island universes was proving to be a comforting illusion. These images whispered of a hidden dynamic, a secret life of galaxies that was anything but peaceful. They hinted that the vast emptiness between the galaxies was not an unbridgeable chasm, but a stage for epic events. The neat and tidy classifications of the Hubble tuning fork began to look less like a complete catalogue of finished forms and more like a snapshot, a single frame, in a much longer, more violent and transformative film. The peculiar galaxies were not a separate class of object. They were perhaps a glimpse of a process. They were galaxies caught in the act of becoming something else, their bizarre shapes, the temporary scars of a momentous encounter. The universe was not a silent museum of static exhibits. It was a dynamic, evolving ecosystem where the inhabitants could and evidently did interact in profound ways. The mystery was no longer about what galaxies are, but about what they do to each other. Those ghostly tendrils and shattered cores were signposts pointing towards a revolutionary new understanding, a new physics of the cosmos that operated on the grandest possible scales. The implications were immense. If galaxies were not isolated, if they could be gravitationally mauled and reshaped, then our own Milky Way was not necessarily safe in its splendid isolation. We too were on a journey through this crowded, chaotic universe. The cosmic dance had begun, and its rules were a complete unknown. What happens when these titans, these continents of stars, finally meet? What unseen forces could possibly be powerful enough to warp and remake something as vast as an entire galaxy? The silent heavens were beginning to speak, and they were telling a story of unimaginable power of collision and of cosmic transformation. And so the mystery deepened, hanging in the cosmic dark like the very celestial ghosts it sought to explain. Hulton Arp's strange and wonderful atlas presented a universe that refused to conform a gallery of portraits, so twisted and disturbed they seemed to cry out with a story we simply lacked the language to comprehend. For decades we had held onto a comfortable, almost stately vision of the cosmos, a universe of majestic, isolated islands, each spinning in serene solitude, evolving at its own pace, governed by its own internal clockwork. These peculiar galaxies were the unsettling exception, the anomalies filed away as cosmic curiosities, perhaps the result of some unknown internal violence, some explosive self-destructive fit. The alternative, the idea that these galactic titans separated by gulfs of space-time that defy human imagination, could actually reach across the void and physically interact, seemed less like science and more like myth. It was a notion so audacious, so contrary to our sense of scale that it bordered on the absurd. Yet the clues were beginning to accumulate faint whispers that would soon grow into a deafening roar demanding a complete rewrite of our cosmic narrative. The first true revolution in our understanding began not in a mind but in a mountain cathedral of steel and glass. High atop Palomar Mountain in California, a new eye opened the 200-inch Hale telescope, a colossal light bucket capable of peering deeper into the universe than ever before. With this magnificent instrument, astronomers were no longer just seeing the bright, chaotic cores of Arp's galaxies. They were capturing the impossibly faint peripheries, the delicate ethereal wisps of light surrounding them. And what they found there changed everything. They saw them faint, luminous bridges of stars stretching between galaxies like shimmering spider silk. They discovered vast arching tails of light, great plumes of stars and gas flung out into the intergalactic abyss, extending for hundreds of thousands of light years. These were not self-contained explosions. They were structures of connection, of relationship. The smoking gun was no longer merely smoking. It was blazing. Look at the Whirlpool Galaxy M51, one of the sky's most famous spirals. For years, its smaller companion was thought to be a background object, a chance alignment. But the deep images from Palomar reveal the truth in breathtaking detail. An elegant arm of the larger spiral didn't just end. It flowed seamlessly across the void, physically connecting to the smaller galaxy, as if M51 were reaching out with a gravitational tendril to ensnare its diminutive partner. Suddenly, Arp's entire atlas began to look different. Systems like the antennae galaxies were not two separate explosive objects that happened to be near each other. Their two long curving tails, reminiscent of an insect's feelers, were clearly being drawn out from the galactic bodies, pointing away from a central point of violent convergence. The evidence was becoming undeniable. These were not islands. These were dancers caught mid-performance in a chaotic gravitational ballet that spanned entire epochs. This burgeoning realization presented a profound challenge, not just to our science, but to our very intuition. To grasp the sheer improbability of it all, imagine our own Sun. If you were to shrink it down to the size of an orange, its nearest stellar neighbour Proxima Centauri would be another orange over 2,000 kilometres away. The stars within a galaxy are incredibly fantastically far apart, so how then could two galaxies collide? The word itself is a misnomer trap set by our terrestrial experience. When we think of a collision, we picture a car crash, a sudden violent impact of solid objects, a maelstrom of twisted metal. But a galactic interaction is nothing like that. It is a far stranger, slower and more ghostly affair. The stars themselves almost never collide. The immense distances between them mean that when two galaxies merge, their stellar populations simply pass through one another, like two swarms of phantom bees interpenetrating without a single impact. The real story, the source of all the dramatic distortion and chaos, lies not in collisions of matter, but in the relentless invisible force that orchestrates all cosmic motion, gravity. And to understand how gravity could sculpt such masterpieces of destruction, we had to move beyond the telescope. We had to build a universe of our own. The problem was a computational nightmare. Calculating the gravitational pull of a few objects, the Sun, the Earth, the Moon, is a classic physics problem. But a galaxy contains hundreds of billions of stars, each one pulling on every other star. The sheer number of interactions was beyond the reach of any human mind, beyond any calculation done by hand. It was a puzzle that could only be solved by a new kind of tool, one that was just beginning to find its footing in the 1960s and 70s, the electronic computer. In the nascent field of computational astrophysics, pioneers like brothers Allar and Juri Tumre at MIT embarked on one of the most audacious projects imaginable. They sought to perform a kind of computational alchemy, to take the raw equations of Newtonian gravity and use them to create and destroy galaxies inside a machine. Their early computers were primitive by today's standards, vast rooms of humming magnetic tape reels and vacuum tubes, with less processing power than a modern wristwatch. Yet within these machines they programmed a simplified cosmos. They represented each galaxy not as billions of individual stars, but as a collection of a few hundred or a few thousand points of light, each one a proxy for millions of suns, each endowed with mass and a starting velocity. It was a ghost of a galaxy, a sketch, but it was enough. They would place two of these pristine virtual disk galaxies on a collision course within their digital universe press, run, and wait for gravity to do its work. What they were truly modelling was the immense power of something we experience every day in a much gentler form: tidal forces. We see it in the oceans as the moon's gravity pulls more strongly on the side of Earth facing it, and more weakly on the side facing away, stretching our planet's liquid envelope into two bulges. Now amplify that principle to a cosmic scale. As one galaxy approaches another, its gravitational field begins to tug on its neighbour. But this pull is not uniform. The side of the galaxy closer to the intruder feels a much stronger gravitational attraction than the side that is farther away. This differential is the key. It is a cosmic rack, a gravitational torture device that begins to stretch the victim galaxy along the line of attack. The near side is pulled forward, forming a bridge of material that flows toward the aggressor galaxy. Simultaneously, the far side, feeling the weakest pull, gets left behind, lagging in its orbit and stretching out in the opposite direction to form a long trailing tail. It is an inexorable, silent process of dismemberment, where a galaxy's own stars are turned against it, pulled from their stately circular orbits and flung out into the lonely darkness of intergalactic space. The Tumorous simulations brought this brutal elegance to life. On their screens, two perfect spirals would begin their pass. At first, nothing seemed to happen. But as they drew closer, invisible gravitational tendrils began their work. The outer arms of the spirals would begin to warp to lift away from the main disk. Then, as the galactic cores made their closest approach, the chaos would be unleashed. One galaxy would pull a magnificent luminous arm from the other, a bridge of stars that shone brightly in the simulation. From the far sides of both galaxies, enormous sweeping tails would erupt, curving gracefully through the virtual space. The stars, once locked in orderly rotation, were now scattered, their orbits randomized and scrambled into a chaotic, puffy sphere. the beautiful flat disks were being systematically destroyed, their structure irrevocably shattered. The moment of revelation, the true scientific epiphany, came when the Tumors took the final frames of their simulations, these ghostly computer-generated images of tidal disruption, and placed them side by side with the deep sky photographs being taken at Palomar Observatory. The resemblance was uncanny. It was perfect. Suddenly, Holton Arp's catalogue of peculiarities was no longer peculiar. The bizarre shape of the antennae galaxies with their two opposing tails was not just a curiosity. It was the textbook result of a direct head-on passage of two disk galaxies captured in a frame from their model. The faint bridge connecting the Whirlpool galaxy to its companion was precisely what their simulation predicted for a grazing encounter. System after system, the strange loops, the distorted arms, the shells and plumes of light seen in the real universe were being perfectly replicated by their simple model, a model based on nothing more than the universal law of gravity. It was a Rosetta Stone for galactic archaeology. For the first time, we could look at a distorted galaxy and not just see its present state of chaos. We could read its history. We could rewind the cosmic clock, understanding the trajectory, the angle of impact, the mass of the dancers. The simulations proved beyond any reasonable doubt that these galaxies were not suffering from some internal malady. They were survivors of, or participants in, some of the most stupendous gravitational events in the cosmos. The paradigm had shattered. The age of isolated island universes was over. The era of the interacting cosmos had begun. This new understanding fundamentally changed our view of the universe. Galactic interactions were not rare freak accidents. The simulations, combined with ever deeper telescopic surveys, revealed they were a common, even essential part of cosmic evolution. Galaxies, especially in the crowded environments of clusters, are constantly jostling, harassing, and influencing one another. Most of these are minor distant encounters, flybys that might warp a disk or ruffle some outer arms. But every few billion years, for a typical galaxy like our own, a major event is likely a true merger, a dance to the death where two become one. This was a profound insight. The grand giant elliptical galaxies that dominate the hearts of galaxy clusters, those enormous sphere-like cities of ancient stars, were likely not born that way. They are the result of countless acts of galactic cannibalism built up over cosmic time through a series of mergers, their original spiral structures utterly erased by the violence of the encounters. Galaxies are not static museum pieces. They are living, evolving systems, and their primary mode of evolution is through interaction. And just as this new worldview was solidifying, we launched a new eye into the heavens, one that would give us a perspective of unimaginable clarity and depth. Floating high above the distorting haze of the Earth's atmosphere, the Hubble Space Telescope began to send back images that turned the ghostly sketches from Palomar into high-resolution masterpieces. If Palomar and the Tumri simulations wrote the book on galactic interactions, Hubble provided the stunning full-colour illustrations. Where ground-based telescopes saw faint fuzzy tidal tails, Hubble saw the individual components within them. It resolved the tails into millions of discrete points of light, revealing that they were not just smooth rivers of stars. They were dotted with brilliant blue knots of light, enormous clusters of newborn stars, tidal dwarf galaxies forged in the fury of the interaction. The gravitational forces that ripped the galaxies apart were also compressing their vast clouds of interstellar gas and dust, triggering furious bursts of star formation. The dance was not just one of destruction, it was also a crucible of creation. Hubble peered into the chaotic hearts of merging systems like the antennae and saw a spectacle of celestial fireworks. Supernova explosions flashed like cosmic strobes. Shockwaves from colliding gas clouds radiated outwards, igniting the birth of millions of massive hot young stars that bathed the scene in an eerie, brilliant glow. We could now see in excruciating detail the consequences of the dance, the life and death cycle, playing out on a scale of 100,000 light-years. The evidence was absolute, written in the light of newborn stars and the gravitational arcs of exiled suns. The universe was far more violent, more dynamic, and more interconnected than we had ever dared to believe. We had solved the mystery of the peculiar shapes. We understood the engine of tidal forces, the gravitational choreography that could bend and break the largest structures in the cosmos. We had witnessed through the twin eyes of simulation and observation the brutal beauty of these celestial encounters. But this revelation only opened the door to a new, deeper set of questions. We had observed the grand performance from the outside, but what was happening deep within the cores of these colliding giants? What becomes of the billions of individual stars and planets caught within this maelstrom? And what is the ultimate fate of the sleeping monsters that we know lurk at the heart of every major galaxy? They're supermassive black holes. The dance was just the beginning. The truly transformative part of the story, the part that would forge new galaxies and awaken cosmic beasts, was about to unfold in the heart of the storm. For so long we have been captivated by the spectacle. The gravitational tides, those gossamer arms of light stretching across millions of light years, were seen as the breathtaking scars of a cosmic accident. The stellar streams, glittering rivers of orphaned stars were tragic monuments to a chance encounter. We watched these celestial ballets as if they were beautiful, violent anomalies in an otherwise orderly and predictable universe. But what if we have been fundamentally misreading the story? What if the chaos we witness is not the exception to the rule of galactic life? What if this dance in all its devastating grandeur is the rule? What if these collisions are not the end of a galaxy's story, but the very engine that writes the next chapter? The truth unearthed from the deepest cosmological simulations and confirmed by observations of the most distant galaxies is more profound than we ever imagined. These interactions are not merely cosmetic. They are not simply reshaping the peripheries of these great star cities. They are the primary architects of galactic evolution itself, the crucibles in which the very identity of a galaxy is forged, shattered, and utterly remade. To understand this transformation, you must first let go of the idea of a galaxy as a solid, fixed object. Instead, you must see it as we now do, a delicate, self-gravitating system of billions or even trillions of individual stars, each locked in a majestic, lonely orbit around a common center. In a spiral galaxy like our own Milky Way, these orbits are astonishingly orderly. The vast majority of stars move in the same direction within the same flattened plane, creating the magnificent spinning disk that defines its structure. It is a system in a state of exquisite dynamic equilibrium, a gravitational gyroscope spinning for eons. A major merger is the catastrophic event that breaks this equilibrium forever. When two such spinning disks, two of these immense gyroscopes collide, the combined gravitational forces are too complex, too chaotic to be resolved peacefully. The stars themselves, being so incredibly far apart, almost never physically hit one another. But their paths, their elegant clockwork orbits, are violently and irrevocably scrambled. Imagine hurling two spinning platters of fine sand at one another. The sand grains our stars fly past each other, but their collective momentum and gravity throw every single trajectory into disarray. The neat planar motion is obliterated. Stars that once orbited serenely in the disk are flung high above and far below that original plane, their paths twisted into new eccentric three-dimensional orbits. They are no longer part of a coordinated rotation. They are now a swarm, a buzzing incandescent hive of randomized motion. The beautiful delicate spiral arms, which are just transient waves of density in the disk, are completely erased by this gravitational maelstrom. The galaxy's fundamental angular momentum is redistributed and effectively cancelled out. What is left in the aftermath after the chaos subsides over hundreds of millions of years is no longer a majestic spiral. It is something new, a vast rounded featureless ball of stars we call an elliptical galaxy. This isn't just a change in appearance, it is a change in character, a fundamental rewriting of a galaxy's celestial DNA. The dance has not just rearranged the furniture, it has demolished the old house and used the rubble to build a completely different kind of structure in its place. The universe, it turns out, uses collisions to transform its spiral cities of ongoing creation into these mature, quiescent elliptical metropolises. This structural metamorphosis, however, is only the beginning of the story. The true alchemy of the merger happens not to the stars but to the vast, cold, dark reservoirs of gas and dust that lie between them. In an isolated galaxy, this interstellar medium is the cradle of creation, a nursery where new stars are born at a slow, sustainable pace. A few new suns every year, a gentle cosmic simmer. But a galactic collision turns this gentle simmer into a violent, explosive flash boil. As the two galaxies plough through each other, their enormous clouds of gas and dust, each spanning hundreds of light years, cannot simply pass through one another like the stars do. They collide directly, creating immense shock waves that ram through the interstellar medium at thousands of kilometers per second. This is cosmic compression on an unimaginable scale. These shock waves act like a gigantic piston squeezing the diffuse gas with titanic force. Vast regions that were once stable are suddenly compressed beyond their critical density, the point at which their own self-gravity takes over and initiates a runaway collapse. Everywhere across the merging galaxies, the lights begin to turn on, not by the dozens, but by the millions. The collision triggers a galaxy-wide firestorm of star formation, a starburst, so intense it can outshine the entire galaxy in which it resides. The rate of starbirth can skyrocket from a few suns per year to hundreds, even thousands. The merging system becomes a celestial furnace blazing with the brilliant blue-white light of countless young massive stars. These newborn giants live fast and die young, burning through their nuclear fuel in a geological blink of an eye. Their ferocious ultraviolet radiation ionizes the surrounding gas, causing it to glow in brilliant shades of pink and red, creating the spectacular emission nebulae we see woven throughout interacting systems. The sheer violence of their birth tears the galactic clouds apart, while their eventual deaths in supernova explosions further roil the gas, seeding it with the heavy elements that will form the next generation of stars and planets. This is the universe's most powerful engine of renewal. A merger doesn't just build a new galactic structure, it furiously populates that new structure with a whole new generation of stars, consuming a vast fraction of its available gas reserves in a single, spectacular burst of creation. Yet deep within the heart of this creative maelstrom, the collision awakens something far older, far more powerful, and infinitely more mysterious. Buried at the core of nearly every massive galaxy, including our own lies, a monster. A supermassive black hole, a gravitational singularity containing the mass of millions, or even billions of suns, typically lies dormant quietly, slumbering in the galactic center. It is a sleeping giant starved of fuel. In an undisturbed galaxy, stars and gas clouds orbit the center at a safe distance kept at bay by the conservation of their own angular momentum. They are trapped in a gravitational dance, but one that prevents them from falling into the abyss. A merger shatters this delicate truce. The same gravitational chaos that scrambles stellar orbits also acts as a terrifyingly efficient funnel. It robs gas clouds and unfortunate stars of their orbital energy, sending them spiraling inward on a one-way journey toward the galactic core. The sleeping monster is about to be fed. As this torrent of matter cascades toward the black hole, it doesn't fall straight in. Instead, it forms a swirling incandescent whirlpool of material called an accretion disk. Here matter is accelerated to near the speed of light, crushed and superheated by unimaginable friction and tidal forces. The disk begins to glow with a ferocity that can defy comprehension, blazing with the light of 1 trillion suns, pouring out radiation across the entire electromagnetic spectrum from radio waves to gamma rays. For a time, this tiny region at the galaxy's heart can outshine all the hundreds of billions of stars in the galaxy combined. The dormant core has ignited, becoming what we call an active galactic nucleus, or AGN. In its most extreme form, it becomes a quasar, the most luminous object in the entire universe. This is not merely a sideshow to the merger, it is arguably its most profound consequence. The awakened black hole, now a ravenous engine of cosmic destruction and creation, becomes an active participant in the evolution of its host galaxy. It doesn't just consume, it pushes back. The intense radiation pressure from the accretion disk can act like a celestial blowtorch blasting outward from the galactic center. In some cases, powerful focused jets of particles traveling at nearly the speed of light are launched from the black hole's poles, punching clear through the entire galaxy and extending for millions of light years into intergalactic space. This outpouring of energy, known as AGN feedback, can heat up or even completely expel the remaining gas from the newly formed galaxy. In a stroke, the supermassive black hole can shut down the very starburst that its merger ignited. It effectively sterilizes the galaxy, quenching any significant future star formation. This act determines the galaxy's ultimate fate. It ensures that the newly formed elliptical galaxy will not regrow a disk, that it will not birth new stars, that it will instead age into a red and dead relic, populated only by old, long-lived stars. The dance of galaxies, it seems, leads directly to the waking of the monster at the centre, a monster that then dictates the final destiny of its own home. However, not every galactic interaction is this cataclysmic drama of equals. The cosmic dance has many different choreographies. For every major merger between two massive spirals, there are dozens of more subtle, more intimate encounters. The universe is overwhelmingly populated by small dwarf galaxies, which swarm around larger galaxies like moths around a flame, and inevitably they are drawn in. This process, known as galactic cannibalism, is a far more common and more persistent driver of growth. A large galaxy like our Milky Way is constantly accreting these smaller systems. The gravitational tides of the larger galaxy are simply too powerful for the dwarf to resist. It is stretched, distorted, and ultimately shredded, its stars pulled away to form those long, faint stellar streams that we now see wrapping around our own galaxy and others like it. Each one is the ghost of a consumed companion, a remnant of a cosmic meal. This is not transformation, it is a process of slow, steady accumulation. Each minor merger adds its stars, its gas, and its dark matter to the larger galaxy, helping it to grow over billions of years. It's like a river slowly building a delta grain by grain, rather than a flood carving a new canyon in a single night. This gentle accretion thickens, the stellar disk puffs up the central bulge and adds to the vast spherical halo of stars that surrounds the main galaxy. Our own Milky Way is a composite being built from the remains of countless smaller galaxies it has devoured over its long history. We are living inside a structure that has been assembled piece by piece through a long and ongoing series of these minor mergers. This constant simmering interaction is just as crucial to the story of galaxy evolution as the rare, spectacular collisions of giants. It is the steady background rhythm of the cosmos, the process that ensures the largest galaxies continue to grow ever larger, fed by an endless supply of smaller victims. It is a quieter dance, but one that never truly ends. And this brings the entire epic, sprawling story of cosmic collisions to a place that is both awe-inspiring and deeply personal. It brings it right here to our own doorstep, because we are not merely spectators to this grand celestial dance. We are participants. We live inside a galaxy that is itself a product of countless past mergers, and more profoundly, we live inside a galaxy that is hurtling toward the most significant collision in its entire history. For decades, we have watched the Andromeda Galaxy, our closest major galactic neighbour, as a beautiful spiral island in the sky, some 2.5 million light-years away. But through careful measurements of the Doppler shift in its starlight, we have made a stunning discovery. Every other distant galaxy is rushing away from us, carried by the expansion of the universe, but not Andromeda. Andromeda is coming right for us. It is falling toward the Milky Way, pulled by our mutual gravity at a speed of over 100 kilometers every single second. There is no ambiguity in the physics. There is no escaping the inevitable. The Milky Way and Andromeda are gravitationally bound, locked in an intricate orbital dance that will in roughly 4.5 billion years culminate in a direct collision. This is our cosmic destiny. The grand drama we have been exploring throughout the universe is not just something that happens to other galaxies. It is the scripted future for our own. Long before the collision itself, our distant descendants, should they exist, will have the most spectacular view in the history of astronomy. Night after night, year after year, the faint fuzzy patch of Andromeda will grow larger and brighter in the sky. Over millions of years, it will swell to become a magnificent sprawling band of light, a rival to the Milky Way's own arc, its spiral arms becoming visible to the naked eye. It will be a sight of terrifying beauty, a celestial hourglass counting down to the moment of first contact. Then the dance will begin. The first pass will send brilliant tidal tails of stars and gas arcing across the sky. The heavens will be crisscrossed with these new brilliant streams of light. Our solar system will almost certainly be safe from any direct stellar encounter, likely thrown into a new wider orbit within the merging system. But the galaxy around us will ignite. A furious starburst will be triggered, lighting up the interstellar medium and creating dazzling new nebulae that will paint the night sky. The two supermassive black holes at the centres of our galaxies will begin their long spiral inward toward one another, eventually merging to form a single more massive behemoth, likely unleashing a quasar-like outburst that will illuminate the core of the new galaxy. After 1 billion years of chaotic interaction of passes and gravitational scrambling, the skies will settle. The two great spirals will be gone, their beautiful disks erased forever. In their place will be a single gigantic elliptical galaxy, a new creation born from the union of two of the local group's titans. We have even given it a name, Milky. Looking out at the cosmos at the tangled remains of interacting galaxies, we are not just looking at distant astronomical phenomena, we are looking at a preview of our own future. We are seeing the ghost of galaxies yet to come. The dance is not remote. The dance is our home's ultimate fate, and so the silent gravitational overture ends. The first tentative touch gives way to a cataclysm of unimaginable scale, a shock wave not of sound but of space-time itself, propagating through both kingdoms of stars. What was once a graceful arcing approach has now become a full-blown physical confrontation, a maelstrom of cosmic forces unleashed. Imagine two vast swirling weather systems, each a delicate balance of pressure and rotation suddenly colliding. The result is not a gentle merging, but a violent explosion of concentrated energy. Here in the void, the medium isn't air. It is the lifeblood of galaxies themselves, colossal ethereal clouds of hydrogen gas. For eons, these nebulae have drifted in serene contemplation, their delicate tendrils harbouring the potential for future suns. They were cosmic nurseries patiently waiting for the quiet internal hand of gravity to knit them into new stars over millions of years. But that time is gone. The stately pace of creation has been shattered. The tidal forces we witnessed beginning their work now surge through the galactic disks like a tsunami. These gravitational waves are a physical compression, a cosmic vice squeezing the vast diffuse clouds of gas and dust with titanic force. The once placid nurseries are shocked into a violent frenzy. Density skyrockets. Temperatures within the clouds soar from just above absolute zero to thousands of degrees in a geological blink. Everywhere this shockwave passes, it triggers a cascade of collapse. Countless cores within the nebulae, which would have taken aeons to mature, are now pushed over the precipice of stability all at once. A firestorm of creation is ignited. This is what astronomers call a starburst. It is not merely an increase in the rate of star formation. It is a galaxy-wide conflagration, a desperate, brilliant fever of stellar birth. Look here at the famous antennae galaxies. Their long, graceful tidal tails tell the story of their recent past, but the heart of their interaction is this chaotic incandescent region where the two disks are interpenetrating. The imagery captured by our most powerful telescopes is not of a serene starfield, but of a celestial battlefield ablaze with light. Those brilliant knots of shimmering blue and violet are not single stars. They are superstar clusters, each containing hundreds of thousands, even millions of newborn suns, all bursting into existence in a breathtakingly short span of time. A typical galaxy like our own Milky Way might leisurely form a handful of new stars each year, drawing from its gas reserves with a measured and sustainable pace. A starburst galaxy in its frenzied state can forge hundreds, sometimes even thousands of new stars in the same period. It is a process of furious, almost panicked creation. The light from this event is overwhelmingly, blindingly blue. This is a crucial clue to the nature of the firestorm. In this high-pressure environment, the scales are tipped in favour of cosmic giants. The starburst preferentially creates massive heavyweight stars, blue supergiants, and hypergiants weighing tens or even hundreds of times the mass of our own sun. These are the titans of the stellar world. They burn hotter, shine brighter, and live far more extravagant lives than their smaller, more conservative cousins. Their intense ultraviolet radiation ionizes the surrounding hydrogen gas, causing it to glow with the characteristic magenta hue you see painting the spaces between the blue clusters. The entire galaxy becomes a canvas of violent ephemeral beauty. For a brief cosmic moment, the interacting system becomes one of the most luminous objects in the universe, a beacon of frantic activity shining across billions of light years. It is a spectacle of unparalleled creative power, a galaxy renewing itself in a single glorious burst of light and energy. But this celestial firework display hides a dark and unavoidable truth. This magnificent galaxy-spanning renaissance is not sustainable. It is in fact a death sentence. Every star, every single point of light born in this frenzy is forged from the galaxy's finite reservoir of gas and dust. This reservoir is the inheritance of a galaxy, the raw material for all its future generations of stars, planets, and perhaps life. A healthy spiral galaxy husbands this resource, carefully drawing upon it slowly over billions of years, ensuring a long and productive future. The starburst throws all of that caution to the void. It is a moment of profound profligacy, a cosmic spending spree that mortgages the galaxy's entire future for one brilliant, fleeting moment of glory. The very giants that make the starburst so spectacular are also the instruments of its doom. Those massive blue stars are insatiable. They consume their nuclear fuel at a truly astonishing rate, burning through their hydrogen, helium, and heavier elements in a mere fraction of the time our Sun will take. While our star is destined for a serene existence of 10 billion years, these blue behemoths are lucky to survive for 10 million. They live fast and they die young, and their deaths are as violent as their lives were brilliant. They do not fade away. They detonate as colossal supernovae explosions so powerful they can briefly outshine the entire galaxy that birthed them. In a normal galaxy, these events are rare, isolated punctuation marks in its long history. But in a starburst with millions of these giants born at once, their deaths become a synchronized percussive onslaught. A wave of self-destruction follows the wave of creation, and each supernova is more than just a final flash of light. It is a phenomenally powerful blast wave that rips through the surrounding interstellar medium. This creates a devastating 1-2 punch against the galaxy's remaining gas reserves. First, the starburst consumes a vast portion of the cool gas, locking it away into stars. Then the subsequent supernova shockwaves blast through what's left, heating it to millions of degrees, and in many cases physically ejecting it from the galaxy altogether. Powerful galactic winds driven by the combined energy of thousands of simultaneous supernovae scour the galaxy clean of its star-forming material, blowing it out into the desolate emptiness of intergalactic space lost forever. The creative fire burns so intensely that it consumes all its fuel, and then its own explosive death throes blow away the ashes. The process is called quenching. It is the end of a galaxy's ability to create. The brilliant blue light of young hot stars fades, never to be replaced. The glowing magenta nurseries go dark. The vibrant dynamic spiral arms once churning with new life grow still and dim. All that remains is the faint ruddy glow of the small ancient long-lived red dwarf stars that were formed long ago and the few survivors from the final burst. The galaxy transitions from a living breathing system into a relic. It becomes what astronomers chillingly call red and dead. A cosmic metropolis once bustling with construction has become a silent museum filled only with monuments to a brilliant bygone era. The very act of creation, when pushed to its most extreme, becomes the ultimate instrument of sterilization. Yet the story of this violent transformation does not end in the fading spiral arms. An even more dramatic, more potent agent of change is being awakened at the very heart of the chaos. While the galaxy's outskirts are ablaze with the fire of new stars, a different kind of storm is brewing in the darkness of its core. For the same gravitational disruption that compresses gas clouds is also playing a terrifying game of cosmic billiards, with the stars and gas clouds orbiting the galactic center. In a stable galaxy, material orbits the central supermassive black hole, at a safe distance held in a delicate balanced dance. Orbits are regular, predictable, almost circular. The monster at the center is dormant sleeping because it is being starved. The collision changes everything. It shatters this stately orbital discipline. Gravitational torques ripple through the galaxy, acting like a giant invisible hand stirring the pot. Stars' gas and dust that have been in stable orbits for billions of years are suddenly nudged, pulled, and thrown onto new, highly eccentric and dangerously chaotic trajectories. Their orbital momentum is violently stripped away. For countless millions of stars and vast streamers of interstellar gas, all paths now lead inward, plunging toward the singularity. A cosmic funnel has been opened, and the sleeping giant is about to be served a feast. Imagine a single massive cloud of hydrogen, 1,000,000 times the mass of our Sun, now on one of these fatal, inwardly spiraling paths. As it gets closer, the black hole's gravity intensifies exponentially. The cloud is stretched and distorted by unimaginable tidal forces drawn out into a long, thin streamer of incandescent matter. It accelerates to a significant fraction of the speed of light, a river of plasma rushing toward oblivion. But it does not fall straight in. Because of its residual spin, the material piles up around the black hole, forming one of the most extreme structures in the entire universe, an accretion disk. This is not some gentle Saturn-like ring. It is a maelstrom of matter, heated to millions of degrees by sheer frictional force, a place where the atoms themselves are torn apart. The magnetic fields within this disk become twisted into colossal, unstable knots of energy. And as the pressure and temperature reach a critical point, the monster awakens. The galactic core ignites. It becomes an active galactic nucleus, or AGN. It is crucial to understand what you are seeing here. The light from an AGN does not come from the black hole itself. Nothing, not even light, can escape from beyond its event horizon. Instead, this incredible luminosity is the death scream of matter in its final moments, before it passes the point of no return. It is the energy of gravitational collapse converted into pure blazing radiation with terrifying efficiency. A single brightly burning AGN can release more energy than all 100 billion stars of its host galaxy combined. It can become the most luminous continuous object in the cosmos, visible from the very edge of the observable universe. The galaxy's core transforms from a point of silent immense gravity into a celestial blowtorch of unimaginable power, and its influence is about to be felt. From the turbulent heart of the accretion disk, where magnetic fields are wound tighter than a cosmic spring, two phenomenal structures are often unleashed. Towering, tightly collimated jets of particles and radiation blasted away from the north and south poles of the black hole at over 99% the speed of light. These jets are galactic in scale, capable of punching clear through the entire host galaxy and travelling for millions of light years into the void of intergalactic space. They are beams of raw power that carve vast empty cavities in the gas surrounding their parent galaxies. The AGN has now become a dominant force, its feedback reshaping the very environment that gave it life. If the starburst was the first fire consuming the galaxy's fuel from within, the AGN is a second, more ferocious fire attacking from the centre out. The intense X-ray and gamma-ray radiation pouring from the accretion disk heats any remaining cool gas in the galaxy, boiling it away, and making it impossible for it to collapse and form new stars. Then the relentless march of the jets provides the final devastating blow, acting like a cosmic snowplow sweeping the galaxy clean of any last remnants of its star-forming reservoir. It is the ultimate act of galactic quenching, a sterilization process so thorough and so violent, it ensures that no new stars will ever form in this galaxy again. The galaxy finds itself trapped in an impossible self-destructive loop. The collision that triggered a magnificent burst of creation also delivered the fuel to awaken the monster at its heart, and that monster in its terrible glory now ensures that the creative fever can never return. The galaxy is caught between two fires, the ephemeral, brilliant blaze of the starburst in its arms, and the enduring, violent furnace of the black hole in its core. One consumes its future, the other scours its present. The dance of these giants has become a trial by fire, and the system that emerges from this crucible will be changed forever, unrecognizable from the two majestic spirals that began this journey. What is left when the fires die down? What new form does a galaxy take after its structure has been obliterated and its creative potential has been extinguished? The dance is not over. Its most profound transformation is yet to come. The fires of creation are beginning to die. Across a battlefield 100,000 light-years wide, the celestial fireworks that lit up the cosmos now sputter and fade. You have witnessed the peak of the cataclysm, the moment of maximum violence, where shockwaves of compressed gas ignited into ephemeral chains of brilliant blue-white stars. It was a glorious, frantic and fleeting burst of life, a final, desperate scream of creation, before an inexorable silence begins to fall. The two galactic hearts, once separated by an impassable void, are now inextricably bound, caught in a gravitational whirlpool from which there is no escape. Their final dance is not one of elegance, but of exhaustion. Look closely at the simulations, our cosmic crystal balls. See how the majestic spiral arms, once graceful rivers of stars, gas and dust, have been torn asunder, their delicate structures utterly annihilated. They have been stretched, distorted and flung outwards into the dark, or have been funneled inwards, consumed in that final spectacular starburst. The galaxies are now mangled beyond recognition, two skeletal cores swinging around a common centre of gravity, bleeding their stellar populations into a single, chaotic, swarming halo of light. This is the endgame, the final few orbits of a billion-year waltz. With each pass, they shed energy into the surrounding sea of stars and dark matter. This process, known as dynamical friction, is like dragging your hand through water. The immense swarm of surrounding matter acts as a brake, robbing the cores of their momentum, pulling them ever closer. The spiral tightens, the pace quickens into a final doomed plunge. And then it happens. The point of no return is crossed. The two dense ancient cores, each containing billions of suns, finally merge. It is not a solid crash, not a clang of cosmic metal, but a ghostly interpenetration, a moment where two rivers of stars flow into one another. In this instant, the gravitational field, the very foundation of the system, goes utterly insane. It fluctuates violently, unpredictably, sending tidal shocks and gravitational waves pulsing through the merging mass. For the countless stars caught within this maelstrom, all the old rules are broken. The placid circular orbits they had followed for eons are erased in a geological blink. This is the moment of violent relaxation, one of the most transformative processes in the universe. Imagine a perfectly layered cocktail with distinct bands of colour. Now take a swizzle stick and stir it frantically, chaotically. The elegant layers vanish, blended into a single uniform mixture. Violent relaxation is gravity's swizzle stick. It takes the beautifully ordered, flattened, rotating disk of a spiral galaxy and scrambles it into a three-dimensional randomized swarm. A star that once orbited sedately within the galactic plane might be flung high above it, then dive deep below its path, now a wild, looping elliptical trajectory. Another might be cast out on a long looping orbit that takes it to the galaxy's farthest fringes, only to return millions of years later, plunging back through the dense central core. The collective sense of direction, the majestic rotation that defined the parent galaxies, is gone. It has been replaced by the fizzing, buzzing, random motion of a swarm of bees. Let us follow the fate of just one star, a sun, much like our own, born in the tranquil suburbs of its former spiral home. For billions of years, its solar system knew only peace, a predictable journey around the galactic centre surrounded by familiar neighbours. But now, its anchor is gone. The gravitational landscape beneath it shifts and bucks like a stormy sea. Our star is suddenly accelerated, pulled onto an entirely new path. It is shot upwards out of the old galactic plane into a blackness it has never known. Looking back, it would see its former home as a churning river of fire. It narrowly misses collisions with other stars, newly intimate strangers, on their own chaotic paths, their gravitational fields tugging and nudging, altering its course yet again. Over millions of years, its wild excursions begin to dampen. The gravitational field of the now fused central mass asserts its new authority, taming the star's chaotic trajectory into a new stable but utterly different orbit. It no longer circles, it soars and plunges, a tiny member of a vast, puffy, spheroidal cloud of stars. It has a new home, a new identity. It is now a citizen of a new kind of galaxy. Multiply this star's harrowing journey by hundreds of billions, and you begin to comprehend the sheer scale of this cosmic restructuring. The very architecture of the galaxy has been rebuilt from the ground up. But as the stars are finding their new places, another more profound change is underway. A creeping famine is setting in after a magnificent feast. The great engines of starbirth, the vast, cold, dense clouds of molecular gas are gone. Where did they go? They were consumed. The merger was spectacularly efficient at taking these clouds, the raw fuel for new suns and new worlds, and compressing them. This compression triggered the ferocious starburst you witnessed earlier, burning through an eon's worth of fuel in a mere flash of cosmic time. What little gas wasn't used up in the firestorm was dealt with just as brutally. The shockwaves from the collision and the energy unleashed by supernovae acted like a celestial blowtorch, heating the remaining gas to millions of degrees. Cold gas collapses to form stars. Hot gas expands. This superheated gas is now too energetic, too diffuse to ever cool and collapse again. It forms a vast invisible halo of sterile plasma surrounding the new galaxy, a ghostly testament to the fires that once were. The stellar nurseries have been dismantled, the lights have gone out, the cosmic assembly line has been permanently shut down, and with this shutdown comes a slow, inevitable transformation of colour and of character. The spiral galaxies that began this dance were vibrant, dynamic places. They were awash in the brilliant blues and whites of massive young hot stars, their arms, traced by the glowing pink of hydrogen nebulae where new stars were being born. They were cosmic cities, bustling with activity and renewal. But the new galaxy, this elliptical giant born of their union, is different. Because no new stars are being born, its stellar population begins to age. One by one, the massive brilliant blue stars which burn through their fuel, with reckless speed, begin to die. They explode as supernovae, leaving behind black holes and neutron stars their intense light, vanishing from the galactic spectrum forever. Over hundreds of millions, then billions of years, this process continues. The blues fade, then the whites, then the brighter yellows. What remains is a population of the universe's great survivors, the long-lived smaller, cooler red dwarfs and ancient yellow suns. The galaxy's overall colour shifts slowly, inexorably along the spectrum. It transforms from a brilliant azure and sapphire to a uniform, homogeneous, ghostly gold. Then, over further eons, it deepens to a sombre, ancient ochre. The galaxy has become what astronomers ominously call red and dead. It is a quiescent city of old stars, a cosmic museum piece. Its creative, vibrant youth is a distant memory replaced by a quiet, majestic, and unchanging old age. How can we be so certain of this incredible story of transformation? Because the universe has left us the evidence. The cosmos is filled with these cosmic fossils. When we turn our telescopes to the great elliptical galaxies that dot the nearby universe, we're not just seeing a single homogeneous ball of stars. We're engaging in a form of cosmic archaeology, uncovering the clues of their violent pasts. Astronomers hunt for the subtle echoes of the merger, the telltale scars of the battle. Look at the galaxy Centaurus AA, nearby elliptical giant. Slashing across its golden glow is a thick dark belt of dust and gas, a feature completely alien to a normal elliptical. This is the undigested remnant of a spiral galaxy. It devoured billions of years ago, a cosmic ghost still haunting its conqueror. In other ellipticals, we find something even more ephemeral. Faint arcing shells of stars arranged in concentric rings like ripples on a cosmic pond. These are the result of stars from a smaller consumed galaxy, sloshing back and forth within the gravitational well of the larger one. Each shell is a snapshot of a single oscillation, a decaying echo of the collision. With our most sensitive instruments, we can trace faint looping streams of stars that extend for hundreds of thousands of light years into the intergalactic dark, the last vestiges of tidal tales from a merger that concluded long ago. We can even analyse the chemistry of different star populations within the same galaxy, finding groups of stars with distinct chemical fingerprints proving they were born in different galaxies before being thrown together in the merger. These are not theoretical possibilities, they're observational facts. The giants that dominate our universe today are built upon the wreckage of their predecessors. They are the victors of a cosmic game of thrones, and they wear the ghosts of their vanquished rivals for all to see. Yet there is one final climactic act of union that occurs in the deepest, most hidden sanctuary. At the heart of each of the original spiral galaxies there lived a monster, a supermassive black hole millions or even billions of times the mass of our Sun. Throughout the merger, these two behemoths, along with their attendant star clusters, sank inexorably toward the centre of the newly forming galaxy. Now, in the crowded, chaotic core, they finally find each other. They begin their own gravitational dance, a spiral far more compact and far more violent, than the one their parent galaxies ever performed. They are 2 points of infinite density, 2 gravitational anchors swinging around each other at unbelievable speeds, approaching the speed of light. This is the most extreme event we can imagine. As they orbit, they do not just disturb the stars around them, they violently churn the very fabric of space-time itself. They are sending out powerful ripples, gravitational waves, that propagate outwards across the universe, carrying away colossal amounts of energy. This emission of gravitational radiation seals their fate. The energy loss causes their orbit to shrink to decay rapidly. They spiral closer faster and faster until in the final milliseconds they merge in a cataclysm that unleashes more energy than all the stars in the visible universe combined. All of it silent. All of it invisible. All of it in the form of a final shuddering tremor in the geometry of reality. In their place, a single, even more massive black hole is born. It quickly settles, its hunger temporarily sated, a new, unchallenged sovereign at the heart of a new unified empire. The dance is now well and truly over. Billions of years have passed since the first touch. The dust has settled. The chaos has subsided into a new kind of order. What remains is no longer a spiral, nor is it simply 2 galaxies smashed together. It is a new celestial entity, a majestic elliptical galaxy. It is a vast serene spheroidal metropolis of perhaps 1 trillion ancient stars, all moving on their randomized intersecting orbits, a self-gravitating system in perfect placid equilibrium. It is larger, more massive, and in many ways more stable than the 2 spirals that gave it birth. The violence of its formation has been transmuted into a profound and lasting peace. There is no gas to fuel new stars, no structure to spawn new spiral arms. Its story of creation is finished. It will now simply hang in the void, slowly imperceptibly aging over the trillions of years to come. It is a monument to the most powerful transformative force in the cosmos, gravity. It has taken 2 of the universe's most beautiful creations, subjected them to a process of unimaginable violence, and forged them into something new, something grander, something final. The giant has been born, a silent testament to a forgotten war. Its creative energies are spent, its stellar nurseries cold and empty. But deep within its core, at the very center of this new quiet kingdom, the newly forged supermassive black hole sits in the dark. It is a sleeping monster, an engine of unimaginable potential, now quiet but surrounded by a fresh supply of stars and gas drawn in by the merger. The great galactic transformation is complete, but it has created a new focal point of power. The giant sleeps. But in the cosmos, sleep is rarely eternal. What does it take to reawaken the beast? And so the crescendo fades. The cataclysm of the merger, a symphony of destruction and creation played out over hundreds of millions of years, finally settles into a new and unfamiliar quiet. What remains is not a ruin, but a renaissance. A single larger entity glowing with the heat of its own violent birth, its shape scrubbed clean of the elegant spiral arms that once defined its parents. We have journeyed from the quiet contemplation of fuzzy smudges in eyepiece of a primitive telescope to the visceral, data-driven reality of cosmic collision. We began with a simple, almost childlike question, born from celestial cartographers like Holton Arp. Why are some galaxies so peculiar? Why do they defy the neat, orderly classifications we tried so desperately to impose upon them? The answer we have discovered is not that they are aberrations from the norm. It is that they are the norm in its most raw and dynamic state. These peculiar galaxies were never monsters, they were monuments. They are the frozen, spectacular moments of a process as fundamental to the cosmos as gravity itself. The dance, a force of change so powerful it dictates the fate of trillions of stars, and yet so patient it unfolds on timescales that dwarf our entire existence. Looking back, we can now see the story of the universe not as a static collection of celestial objects, but as a grand, interconnected narrative of transformation. Every galaxy you see, every island of light in the cosmic ocean, is a character in this ongoing epic, with a past etched in its stellar populations and a future being written by the gravitational tides of its neighbours. We learned to read the clues, the faint ghostly arcs of tidal tales, those ethereal bridges of stars and gas flung into the void, became the telltale signatures of a past encounter, the lingering perfume of a dance partner long since departed. We deciphered the language of starbursts, those brilliant ephemeral nurseries where the collision's shockwaves compress vast clouds of gas into a firestorm of stellar genesis. An entire generation of new suns born not from quiet evolution, but from the violent crucible of a merger, their brilliant blue light a temporary flare signalling a profound metamorphosis. We came to understand that these interactions are not merely cosmetic rearranging stars into new patterns. They are the quintessential engine of galactic evolution, the primary mechanism by which galaxies grow, change and mature. Consider the great dichotomy of the cosmos, the elegant star-forming spiral galaxies like our own, and the vast quiescent elliptical galaxies, the slumbering giants of the universe. For decades their relationship was a mystery. Now we see the through line, the arrow of time connecting them. The dance is that arrow. The chaotic merger of two or more gas-rich spirals, their delicate structures shredded, and their orbital energies randomized, provides the perfect recipe for creating a massive spheroidal elliptical. The very process that rips apart the old order forges the new. The cold gas that once fueled serene star formation in the spiral arms is violently funneled toward the galactic center, consumed in a final brilliant burst of activity that illuminates the cosmos. Once that fuel is exhausted, the new galaxy settles into a long quiet retirement, a majestic red and dead relic populated by ancient stars. Every giant elliptical you observe in a galaxy cluster is likely a testament to a wild and violent youth, the product of a history of repeated cannibalistic mergers. They are the victors of a cosmic battle royale, having absorbed their smaller rivals to achieve their immense size and stature. This process extends beyond the visible matter. The invisible scaffolds of dark matter halos, which we now know cocoon every galaxy, are the primary drivers of the initial encounter. They are the vast unseen hands that guide these celestial partners together across the empty chasm of intergalactic space. As they interpenetrate, the halos themselves merge, creating an even larger, more massive structure that will in turn exert a more powerful gravitational pull on its surroundings. This is how the large-scale structure of the universe, the cosmic web of filaments, clusters and voids, is built. It is a bottom-up construction project on the grandest imaginable scale, with small galaxies merging to form larger ones, and those larger ones congregating along filaments of dark matter drawn inexorably toward the dense gravitationally dominant nodes we call galaxy clusters. Every interaction, every merger, is another thread woven into this immense gravitational tapestry. The dance is not an isolated event. It is the fundamental mechanism that stitches the cosmos together, creating the vast interconnected architecture we observe today. And what of the monsters that lurk in the hearts of these galaxies? The supermassive black holes, millions or even billions of times the mass of our Sun. Their growth too is inextricably linked to the dance. A quiet, isolated galaxy can only feed its central black hole so much, but a merger changes everything. The gravitational chaos acts like a cosmic funnel, driving enormous quantities of gas from the outer regions of the colliding galaxies directly toward the center. This sudden, massive influx of fuel awakens the dormant beast. The black hole begins to feed voraciously, powering the most luminous and energetic phenomena in the known universe, active galactic nuclei and quasars. These are not just objects, they are events. A quasar is the brilliant death scream of gas being consumed by a supermassive black hole, a celestial blowtorch so bright it can outshine its entire host galaxy by a factor of thousands. For a few million years, this beacon blazes across cosmic distances, a clear signpost that a major merger is underway. This feedback loop, where the merger feeds the black hole and the black hole's energetic output then influences the surrounding galaxy, is one of the most crucial relationships in astrophysics. It can regulate star formation blow gas out of the galaxy entirely, and ultimately determine the final mass and state of the newly formed entity. The dance choreographs the growth of not just the stars but of the space-time singularities at their core. Even our own origins are tied to this cosmic ballet. The elements that make up our planet, our bodies, the very iron in our blood were forged in the hearts of stars. But it is the galactic dance that ensures these elements are distributed and recycled. As galaxies collide, they trigger waves of new star formation. These new massive stars live fast and die young, exploding as supernovae that enrich the interstellar medium with heavier elements. The collisions then stir and mix this enriched gas, providing the raw material for the next generation of stars and eventually planets like Earth. Without this constant violent churning, the universe would be a far more chemically simple and likely sterile place. We are in the most literal sense the children of cosmic violence. Our existence is predicated on a long and complex history of galactic mergers that mixed the cosmic cauldron, allowing the necessary ingredients for life to accumulate in one quiet corner of the Milky Way. And that brings the story home to our own cosmic doorstep. We are not merely observers of this grand ballet. We are participants poised for our own curtain call. Our galaxy, the Milky Way, is currently on a collision course with our largest neighbour, the Andromeda Galaxy. Travelling towards each other at over 100 kilometres every second, their gravitational embrace is an inevitability. In about 4.5 billion years, the dance will begin for us. The night sky of a future Earth, should it still exist, will be a spectacle beyond our wildest imaginings. Andromeda will grow from a faint fuzzy patch into a magnificent sprawling structure dominating the heavens, its spiral arms a breathtaking tracery of light. Then, the first pass. The two galactic disks will slice through each other, their stars passing like ghosts in the night due to the immense distances between them. But the gravitational effects will be profound. Tidal tails will be torn from both galaxies, flung into space as brilliant arcing streamers of stars. The sky will be crisscrossed with these new temporary constellations. Vast clouds of gas will collide, triggering a burst of star formation so intense it will light up the interstellar medium, creating a celestial fireworks display that will last for millions of years. After that first violent passage, the two galaxies will pull apart, wounded but still bound by gravity. They will slow stop and then begin to fall back toward each other for a second, even more chaotic encounter. This gravitational oscillation will continue for hundreds of millions of years, a slow, inexorable process of shredding and merging, until the individual identities of the Milky Way and Andromeda are lost forever. They will coalesce into a single giant elliptical galaxy, a new entity some have already christened Milkomeda. Our solar system will likely be flung into a new, much larger orbit, far from its familiar galactic home. The familiar starry river of the Milky Way will be gone, replaced by the diffuse spheroidal glow of a giant elliptical. It is a startling, perhaps even unsettling vision of the distant future. But it is not an ending. It is simply the next stage of our evolution. It is our galaxy's destiny to participate in the same creative process that has shaped the universe since the very beginning. We are living in a quiet interlude, a moment of calm before the storm. The dance awaits us, a powerful reminder that nothing in the cosmos is permanent. To truly grasp the future and to fully understand the past, we are building new eyes instruments of incredible power and precision, designed to peer deeper into the cosmic story. With the James Webb Space Telescope, we have opened a new window onto the universe. Because it sees in the infrared, Webb can pierce through the dense veils of dust that enshroud the hearts of merging galaxies, revealing the frantic starburst nurseries and growing black holes hidden within. More importantly, it is a time machine. Webb is specifically designed to capture the faint red-shifted light from the dawn of time, allowing us to witness the very first galaxies engaging in their very first interactions. We're no longer just studying the mature dances of the modern universe. We are watching the very first steps of the cosmic ballet when the universe was young, and its galaxies were small, gas-rich, and furiously assembling themselves. These primordial mergers were the building blocks of everything that followed, and with Webb we are there in the front row watching cosmic history unfold. We are seeing the faint wispy filaments of cold gas, the cosmic rivers that flowed from the intergalactic medium to feed these nascent galaxies, providing the fuel for their spectacular collisions. On the ground, a new generation of behemoths is rising. Extremely large telescopes with mirrors tens of meters across will gather light with a sensitivity we could once only dream of. They will not just take pictures, they will perform cosmic archaeology. Using advanced spectrographs, they will dissect the light from individual stars and gas clouds within interacting galaxies, even those hundreds of millions of light years away. Each spectrum is a barcode revealing a wealth of information, the chemical composition, the temperature, the density, and the precise velocity of the material. This will allow us to create exquisitely detailed three-dimensional maps of the kinematics and chemistry of a merger as it happens. We will be able to trace the flow of gas as it is funneled toward the central black hole, measure the rate at which new stars are forming in different regions of the collision, and identify which elements are being forged and ejected back into space. We will move from the broad strokes of the dance to understanding the intricate choreography of every single step. And where our telescopes cannot go, our minds will venture aided by the most powerful supercomputers ever built. Modern cosmological simulations are no longer simple cartoons of gravity. They are virtual universes in a box-complex ecosystems that incorporate not just the pull of dark matter and stars, but the intricate physics of gas dynamics, magnetic fields, star formation, and feedback from supernova and black holes. These simulations are our celestial laboratories. They allow us to run the cosmic clock forward, backward, and sideways. We can collide digital galaxies with different masses, different gas contents, and from different angles observing the outcome of each unique encounter. We can experiment testing our theories in ways that are impossible through observation alone. The synergy between these simulations and the torrent of new data from telescopes like Webb is the key to our future understanding. Observations will provide the crucial reality checks for our models, while simulations will provide the theoretical framework to interpret what we see. Together they will allow us to build a complete four-dimensional picture of the cosmic dance from its earliest beginnings to its ultimate fate. We find ourselves at a remarkable moment in our quest for understanding. The peculiar galaxies that once baffled astronomers have revealed themselves to be the key storytellers of the cosmos. They are not oddities, they are the process of creation made visible. They have taught us that the universe is not a tranquil static place. It is a dynamic, evolving, and at times breathtakingly violent arena. The story of the cosmos is a story of interaction, of connection, of transformation driven by the most fundamental force of all. The dance is perpetual. It happened billions of years ago, shaping the first galaxies from the primordial fog. It is happening now in spectacular fashion, in systems like the antennae and the whirlpool, and it will happen in our own future, when our Milky Way steps onto the cosmic stage with Andromeda for their final transformative performance. From our tiny, fragile world, we look out into the deep, and we no longer see a collection of isolated islands in an endless void. We see a single, grand, interconnected system constantly in motion, forever remaking itself through this magnificent cosmic ballet. The dance goes on, and we're finally beginning to understand its steps.